IBM WebSphere MQ administration. Here MQ stands for message queuing. WebSphere MQ enables communication between distributed applications over the network. It is known as an integration engine. It integrates distributed applications irrespective of the platform, programming language, and protocol. Here you can see two distributed systems. They are Windows and Linux. On Windows host, an application hosted. Its name is business service. This business service might be implemented in C programming language or in C++, Java or in .NET. One more application hosted on Linux. Its name is business operation. This application might be developed in C or in C++ or in Java or in .NET. In between these two distributed applications, we want to enable reliable communication. For that, here we configure an integration engine. It is IBM MQ server. Here it provides an interface MQ API. Programmers need to develop MQ API to exchange data as messages over the IBM MQ server. Now my business service wants to exchange data with business operation. Business service here defines its data as message. Message is collection of data. MQ message consists two parts. They are MQMD header and the payload. Payload known as message body. In message body, application may insert XML data, text data, binary data, anything. This is how application creates message. It connects IBM MQ server. It puts message in queue. Queue is an object. Queue is file and data structure. It holds messages. Here put is nothing but write. Application connects IBM MQ server. It opens queue and it performs put operation. If remote application available on online, it connects IBM MQ server. It gets message off from the queue. Here get is nothing but read. When an application retrieves message from MQ server, the message no more. MQ server supports once and only once delivery and guaranteed delivery. WebSphere MQ, also known as store and forward mechanism. An application stores data as messages at MQ server. When remote service requests the data, it forwards. Here it is just like passbook. An application deposits data. An application draws the data. When an application draws the data from MQ server, the data no more. Are you clear? I repeat all the statements together. Listen me. WebSphere MQ built on Java. It is platform independent. It supports 80 plus platforms. It is available on a large number of platforms like Windows, Unix, AS400, mainframes, and etc. It is an IBM middleware message transport product. It enables communication between distributed applications over the network. It is an integration engine. It integrates distributed applications irrespective of the platform, programming language, and the protocol by providing an interface MQ API. MQ API available to all the programming languages to make the programs to connect IBM MQ server and to perform put and get operations. MQ server known as store and forward mechanism with assured delivery. It is just like passbook. Yes, his name is Uday.
Yes, sir.
You know very well bank passbook, right? In bank passbook, what the transactions we can see? Credit and debit. If we deposit money, they credit amount on our account. If we withdraw money, they debit amount on our account, right? Once if you draw the money no more on account, right? Here also the same. An application puts data, an application gets data. When an application gets data, the data no more. Here an application can draw the data once and only once. Here WebSphere MQ can route the data. It cannot transform the data. It cannot perform any kind of operations on message. See here, business service is owner of the message. It is created message. It's delivered message to MQ server. Here MQ server, what it can do, it can hold that message. That's it. It cannot validate message data. It cannot provide any type of data to message body. It does not perform any kind of operations or any type of operations on message. Just it holds the message. If remote application requests the data, just simply forward. Okay. Look at this PPT. Up to this, are you clear here?
Yes.
Yes. See here, messaging is the mechanism to define data as message to exchange over the network. Developers are going to implement MQ API, right? Then programs can define data as messages to exchange with the remote application over the network. Queuing is the mechanism to hold messages until unless remote services process them. Look at here. Same thing. I show you. Business service implemented with MQ API. Business service is able to define its data as message to exchange data over the network with a remote application. See, it's sending data as messages to MQ server. In MQ server, object queue holds the data. If remote service requests the data, simply it forwards. Here MQ message consists two parts. They are MQMD header and message body. In message body, application may insert XML data, text data, binary data, anything. IBM MQ server does not care about the message data. Okay, application can insert any type of data in MQ message body. It can exchange with the remote application. MQ server does not create messages. It does not provide any data to the messages. Just it can hold and it can forward. This is sample MQ message image. Here you can see message descriptor. Message descriptor describes the message. It contains message ID, message expiry information, message type, message persistence. which application defined this message, on which date, at what time this message is created by the application. That kind of metadata, control data is contained by MQMD header. Message body contains actual business data. Okay, here the data may available as text, as XML, as binary. The format can be anything. If you compare IBM MQ server with the DB engine, it is easy to understand, Uday. You know very well, in DB engine we create tables to hold data as records permanently, right? Uday, what we create in DB engine to hold data?
Tables.
Tables. Tables are going to hold data as records permanently, right?
Yes.
So whereas in MQ server, we create queues to hold data as messages until processed by remote application. See here, sender application sending messages to Q1 and Q2. In between these two resource managers, an application hosted, it wants to get data from MQ server and it wants to insert the data into the database. So what it can do here, it opens connection to IBM WebSphere MQ server and it opens connection to DB engine. It starts transaction with two-phase commit. Then it gets the data from MQ server, it inserts the data into the database. See here, here table holds the data, here queue holds the data. Here data stored as record, here data stored as message. Here it is permanent storage, here it is temporary storage. Once if you insert the data into the database, we can extract n number of times until we delete. Whereas in MQ server, once if we place the retrieve operation on message from queue, the message no more. Okay. I hope you are clear. Between applications, we can enable one-way communication and two-way communication. Here, between application A and B, we enable one-way communication. If you want to enable two-way communication, you can enable. Here, application A putting request message on Q1, it's getting reply message on Q2. Application B getting request message from Q1, it's putting reply message in Q2. At the same time, MQ applications, that means applications can run at different times. So we can enable time independent communication between applications over the network with the help of IBM MQ server. Here application is sending messages to Q1 for application B. It is not available right now to get the messages from Q1. So messages will available in Q1 itself. Whenever application B becomes active, it can retrieve messages from Q1. Okay. No constraints on application structure. Any kind of communication possible between the applications, one to one, one to many to one, many to many. No constraints on application structure. Okay. See what IBM says about MQ: once and only once delivery and guarantee delivery. You know very well, Java is nothing but an object, right? Yes, please. Java nothing but an object, right?
Yes.
Yeah. Mm-hmm.
WebSphere MQ built on Java. In MQ series, everything we create as an object. Here objects are predefined, madam. MQ predefined objects are 7. They are queue manager, queue, channel, listener, process, name list, and service. MQ predefined objects are 7. They are queue manager, queue, channel, listener, process, name list, and service. We must create MQ objects with unique name. To define names to MQ objects, MQ series allowed char set is A to Z capital, A to Z small, 0 to 9 digits. Allowed special characters are dot, slash, mod, underscore. This is the only char set allowed by IBM WebSphere MQ to define names to MQ objects. There is a limitation about length. Object name length can be less than or equal to 48 characters except channel name. Channel name can have less than or equal to 20 characters. Okay. This limitation applicable only to channel name. What is meant by administration? Create, delete, modify, start, stop. All these tasks comes under administration, right, madam?
That's right, Madhu. Yeah.
Here we need to administrate MQ predefined objects. To administrate MQ predefined objects, MQ providing predefined commands. There are three types: control commands, MQSC commands, and PCF commands. As a WMQ system admin, we don't work with PCF commands. We don't work with PCF commands. PCF stands for Programmable Command Format Commands. We don't work with PCF commands. We always work with control commands and MQSC commands. Control commands are around 25. MQSC commands are 15. Control commands we execute at OS level. MQSC commands we execute at MQ server level. Using these three types of predefined commands, we administrate MQ predefined objects. As you know, hardware, operating system. For suppose on this hardware we install Windows. Now this platform becomes Windows platform. On Windows we install Windows MQ, right? Once MQ is installed on Windows, it runs as a service, madam. Hardware, operating system, for suppose here it is Windows. On this Windows host we install Windows MQ. Once MQ is installed on Windows, it runs as a service. On top of this, we host MQ objects, madam. Okay. See here, what it is, madam? WebSphere MQ service. Its status is running, right? If you stop this service, you cannot create MQ predefined objects. The service must be running, then only you can host MQ objects. Listen me, in these 7 predefined MQ objects, Queue Manager is an initial object. It is first and foremost object in IBM WebSphere MQ series. Unless we create Queue Manager, we cannot create rest of the MQ predefined objects. Queue Manager itself, MQ server and MQ engine. It is subsystem, it controls and holds all the MQ predefined objects. Madam, can you write a program in Java programming language without class? Yes, madam. Can you write a program without class in Java programming language?
No.
If you can define the class, in the class you can define the method, right? If you don't define the class, you cannot define the methods.
That's
Class
right.
is going to hold all the methods. Here also the same. Queue manager is an initial object. Unless you create queue manager, you cannot create rest of the MQ predefined objects. Queue manager itself MQ server and MQ engine. It is subsystem. It controls and holds all the MQ predefined objects. Look at here. Very first I create queue manager. Once queue manager object is created, in its control, we can create queues, channel, listener, process, name list, and service. If there is no queue manager, there is no rest of the MQ objects, right? Queue, listener, channel, process, name list, and service. Queue manager provides queuing services to the application. It is single point of contact to all the distributed applications to access MQ queues to perform put and get operations. If an application wants to access queue to perform either put or get operation, first it has to connect the queue manager, right?
Okay.
Application, first it has to connect queue manager. Then only it can access the queue. Queue is a file. Application must open that file to write the data. So open the queue, perform either put or get. After that, close the queue, disconnect from queue manager. In this sequence, applications execute operations on MQ server. Connect, open, perform either put or get, close the queue, disconnect from queue manager. Right? Is it single point of contact or not to all the applications to access queues to perform put and get operations? Yes. I will show you some sample MQ API implementation. Can you read out this, madam?
Yeah, sure. Sample C program that asynchronously puts messages to a message queue.
Right. This is C program, right? C programmer started MQ API implementation in his program. WebSphere MQ providing MQ API as header file to C programming language. See, developer included the header file in his program, right?
Yeah.
He started implementation that API. Very first statement, can you read this?
To queue manager.
Program must connect the queue manager, then only it can access the queue. So to connect to queue manager, what is the method C program executes?
MQ con.
MQ con of queue manager name. Program makes connection to respective queue manager.
Yeah.
After that, application must open the queue to perform either put or get. Can you read out the statement here?
Open the target message queue for output.
What is the function here it executes? MQ open. Right?
Yeah.
Program Open connection on queue manager. It opens queue to put messages. It creates message. If it wants to put message in queue, what is the method what is the function it executes? MQ put, right?
Yeah. Mm-hmm.
If application wants to get the message from queue, it executes MQ get.
Mm-hmm.
After performing either put or get, application must close the queue. To close the queue, application executes MQ close call, right?
Yeah. Yeah.
MQ close function or call. Program wants to disconnect from queue manager. What is the method it executes? MQ delete. Your operations are very clear. Connect, open, perform either put or get, close the queue, disconnect from queue manager, right?
Yeah.
In this sequence only all the distributed applications execute operations on MQ server. I will show you some Java programs how they implement MQ API. You can understand now. IBM WebSphere MQ provides MQ API as header, as jar file to Java programming language. Developer keeps that jar in his class path. He imports all the MQ API packages, right?
Mm-hmm.
In main method, what is the statement here?
Create a connection to queue manager.
See, MQ queue manager is the class, right? To this class, he defines an object.
Mm-hmm.
He provides queue manager name to constructor. So the program makes connection to the queue manager. After that, can you read out this, madam?
Now specify the queue that we wish to open.
Yes.
Okay.
Which queue application which to open to perform either put or get. The queue name it must specify, then it can open the respective queue. What is the statement? Can you read out this?
Define a simple WebSphere MQ message.
Yes, who defines message? Program creates message. Application creates message.
Okay.
MQ server does not create message. It is
Right.
not owner of the message. Just it can hold and it can forward. Yes, after creating the message, if program wants to put message to the queue, what is the method it executes? Queue.put.
Right.
It is similar to MQ put. If application wants to get the message from queue, it executes method queue.get. It is similar to MQ get.
Mm-hmm.
If program wants to close the queue, queue.close. It is similar to MQ close. If program wants to disconnect from queue manager, it executes queue manager.disconnect. It is similar to MQ disk. This is how developers are going to implement MQ API as per their requirement. Okay.
Mm-hmm.
The programs are going to create messages, they connect MQ server, they perform put and get operations here. If you see outline of the MQ series, you can find just 7 predefined objects, right? 40 predefined commands. Major operations are put and get. Data comes to MQ server as message. The message lands in object queue. Just this is WebSphere MQ outline. What is there, right?
Mm-hmm.
As a WMQ admin, you are going to install WMQ on distributed system. You create required MQ predefined objects. You grant authorities to client user IDs to allow them to perform put and get operations. See here, MQSC commands, control commands, all these objects are consistent between platforms. Now I will show you commands in Windows MQ. After that I will show you commands in Linux MQ. The commands are consistent between platforms. Whatever the predefined commands you can execute in the Windows MQ, the same commands you can execute in Linux MQ, in Controller MQ, in AX MQ, in XP Unix MQ. Okay. See here I will show you some MQSC commands and control commands. Already there is a queue manager. Let me get into this. I type something here XYZ. This is plain console, madam. This is plain console. This is known as queue manager control area. Here I am trying to execute something. What it's saying here? Syntax error detected. Valid MQSC commands are as listed below. Right? MQSC commands are normal English words. Also clear, define, delete, display, and ping, refresh, reset, resolve, resume, start, stop, and suspend. Okay. With these commands only, very often we work at this console to administrate MQ predefined objects. Let me go to Linux host. So I have been stopped to that Linux machine. Okay. The commands are same, madam. No change. Any queries here?
So Madhu, run MQSC test, run MQSC command basically connects to the queue manager then?
Yeah, you have to get into the queue manager, right?
Yes.
You create queue manager, you start queue manager. After that you have to get into the queue manager to administrate rest of the MQ objects like queue, channel, listener, process, name list, and service. So to get into the queue manager, you take the help of command run MQSC. Run. What is mean by run in computer language?
Start.
Execute, right? Run means execute or start. Okay. Run MQSC means I want to execute MQSC command in so and so queue manager.
Okay.
See? Run MQSC. I want to execute MQSC commands in this particular queue manager. So run MQSC followed by queue manager name. Starting MQSC for queue manager, test QMGR. See, this particular run MQSC command provided interface to work at MQ server, right?
Okay. Right.
If you want to get into the queue manager, you can get into that. If you want to quit queue manager control area, you can quit. For that, the command is end, right?
Okay.
See, this is OS level. Here also it is OS level. In between these two command prompts, we define an area, right? It is queue manager control area. Get into queue manager. Yes, we are in queue manager control area. Is there any command prompt like this?
No.
Right. No. It is special console. If you want to quit that console, end. Now you are at OS level. If you want to get into the queue manager again, you can get into that. If you want to quit queue manager control area, you can quit it.
Got it. Okay.